Her newspaper obituaries never told her ultimate and timely discoveries. The woman who discovered what the universe is made of, since her death in 1979, has not so much as received a memorial play. In our early years in school, they will tell you, Newton discovered gravity, Albert Einstein wrote about the theory of relativity of time, but when it comes to the never-told story of the discovery of the composition of our universe, the textbooks simply say, the universe has hydrogen as the abundant element. And we wonder not how the Earth got to know. The question is, who then discovered what the sun and the atmosphere is made of? Before we continue, make sure you subscribe, like and share. Oh wait, let me tell you about Cecilia Payne. Cecilia Payne was born in 1900 in Wendover, England. Her mother was not ready to spend money on her education, so she got scholarship into Cambridge University. Upon entering Cambridge, she knew she wanted to study science, but since science is very broad, she wasn't sure of which one she should go for. In a workshop, she got a chance to hear Arthur Eddington, an astronomer, give a public lecture on his recent expedition to observe the 1919 solar eclipse, an observation that proved Einstein's theory of general relativity. She later recalled her exhilaration. She realized that physics was for her, when she was able to recall the lecture word for word when she returned to her room. She told Professor Eddington that she wanted to be an astronomer. Eddington invited her to use the observatory's library, with access to all the latest astronomical journals. This simple gesture opened the world of astronomical research to her. He suggested a number of books for her to read, but she had already read them. Cecilia Payne completed her studies, but Cambridge wouldn't give her a degree because at that time, women were not of much exposure, and had a little chance advancing beyond the teaching role. She left England to the States in 1923, where she met Harlow Shapley, the director of Harvard College Observatory. During this time in Harvard, many people had attempted stellar spectra. In principle, it seemed that one might obtain the composition of the stars by comparing their spectral lines to those of known chemical elements observed in laboratory spectra. Astronomers had identified elements like calcium and iron as responsible for some of the most prominent lines, so they naturally assumed that such heavy elements were among the major constituents of the stars. In fact, Henry Norris Russell at Princeton had concluded that if the Earth's crust were heated to the temperature of the Sun, its spectrum would look nearly the same. When Payne arrived at Harvard, the study of stellar spectra was studied comprehensively. Annie Jump Cannon had sorted the spectra of several 100,000 stars into 7 distinct classes. She had devised and ordered the classification scheme, based on differences in the spectral features. Astronomers assumed that the spectral classes represented a sequence of decreasing surface temperatures of the stars, but no one was able to demonstrate this quantitatively. Cecilia studied the new science of quantum physics, so she knew that the pattern of features in the spectrum of any atom was determined by the configuration of its electrons. She also knew that at high temperatures, one or more electrons are stripped from the atoms, which are then called ions. The Indian physicist M.N. Saha had recently shown how the temperature and pressure in the atmosphere of a star determine the extent to which various atoms are ionized. Payne started a long project to measure the absorption lines in stellar spectra. After 2 years, she produced a thesis for her doctoral degree, the first awarded for work at Harvard College Observatory. In her thesis, she showed that the wide variation in stellar spectra is due mainly to the different ionization states of the atoms and hence different surface temperatures of the stars, not to different amounts of the elements. She calculated the relative amounts of 18 elements and showed that the compositions were nearly the same among the different kinds of stars. She discovered, surprisingly, that the Sun and the other stars are composed almost entirely of hydrogen and helium, the 2 lightest elements. All the heavier elements, like those making up the bulk of the Earth, account for less than 2% of the mass of the stars. Shapley sent Payne's thesis to Professor Russell, who informed her that the result was clearly impossible. To protect her career, Payne inserted a statement in her thesis that the calculated abundances of hydrogen and helium were almost certainly not real. She later converted her thesis into the book Stellar Atmospheres, which was well received by astronomers. In few years it was clear to everyone that her results were both fundamental and correct. Payne had showed for the first time how to read the surface temperature of any star from its spectrum. She showed that Cannon's ordering of the stellar spectral classes was indeed a sequence of decreasing temperatures, and she was able to calculate the temperatures. The so-called Hertzsprung-Russell diagram, A plot of luminosity versus spectral class of the stars could now be properly interpreted, and it became by far the most powerful analytical tool in stellar astrophysics. Cecilia Payne is the reason we know basically anything about variable stars, stars whose brightness as seen from Earth fluctuates. Literally every other study on variable stars is based on her work. When she finished her PhD in 1930s, Payne advised students, conducted research, and lectured all the usual duties of a professor. Yet, because she was a woman, her only title at Harvard was technical assistant to Professor Shapley. Despite being inarguably one of the most brilliant and creative astronomers of the 20th century, Cecilia Payne was never elected to the elite National Academy of Sciences. But times were beginning to change. In 1956, she was finally made a full professor. She was the first woman so recognized at Harvard and is often credited with breaking the glass ceiling for women in the Harvard Science Department and in astronomy. As well as inspiring entire generations of women to take up science, her fellow astronomers certainly came to appreciate her genius. In 1976, the American Astronomical Society awarded her the prestigious Henry Norris Russell Prize. In her acceptance lecture, she said, "The reward of the young scientist is the emotional thrill of being the first person in the history of the world to see something or to understand something." As much as any astronomer, she had fully experienced that most important of all scientific rewards. Cecilia Payne is awesome and everyone should know her. Thank you for watching. Please don't forget to subscribe, like and share for your friends and family to benefit.